Hi everyone. Today I want to talk about the answer to the question, what is physics? Our objectives are going to be to recognize the questions that physics can answer, to list several disciplines within the study of physics, and to define matter, mass, work, and energy. I like to think of physics as the field that answers questions that 2-year-olds love to ask. Why? Why is the sky blue? Why does the wind blow? Why does my teacher smell funny? Why do objects fall down instead of up? Why do airplanes fly? And more importantly, why can't I? Why do stars shine? Even the question, why do I have to eat my vegetables, ultimately relates to physics. So what is physics? If you look it up in the dictionary, it's going to say something about matter, energy, and how they interact. So we'll have to define matter, we'll have to define energy, we'll have to talk about how they interact, and more importantly, answer the question of why do we care? So matter is anything that has mass and takes up space, but mass is the amount of stuff making up an object. So really matter is anything you can touch or feel. A star is matter, electrons are matter, your cat Fluffy is matter, even Neil Diamond, you could touch him, he's matter. Let's take a look at a sample problem about a spacecraft. On the surface of Earth, a spacecraft has a mass of 2 times 10 to the 4 kilograms. What is the mass of the spacecraft when it's a distance of 1 Earth radius above the surface of the Earth? Well, matter, the amount of stuff something's made up of, doesn't really change. Doesn't matter where you are, you're still made up of the same amount of stuff. Therefore, this is somewhat a trick question. The answer is the same, 2 times 10 to the 4th kilograms. Let's take a look at energy. If we look that up in the dictionary, it's probably going to say that energy is the ability or capacity to do work. So if we look up work, it'll say it's the process of moving an object. And realize these are somewhat simplified definitions that we'll expand on later. Let's put those together to say really that energy is the ability or capacity to move an object. And we'll use that as our working definition of energy, at least for the time being. And in the early 20th century, Albert Einstein formalized a relationship between mass and energy. And you've probably seen this formula. A simplified version of it says that energy, E equals m, mass, times the speed of light squared. What he's really doing is he's saying that the mass of an object, which is a characteristic of all matter, is really a measure of how much energy it contains. And some folks would say that that means that matter is highly condensed energy. And there are debates you could have on the semantics of that argument. But for our purposes, we can almost think of matter as being highly condensed energy. Close enough for our purposes at this level. More importantly, and the key concept of the entire course, the source of all energy on Earth is ultimately the conversion of mass into energy. Try and think of a form of energy that didn't originate with the conversion of mass into energy. Most of the energy we think about comes directly from the sun. Well, the sun's energy comes from the conversion of mass into energy, which then transfers through space into Earth, gives us hydroelectric power, gives us the light that feeds our plants that we then eat, or feeds critters that eat the plants and we then eat the critters. The only type of energy I can think of offhand on Earth that doesn't come directly from the sun at the moment is nuclear energy, or chemical energy from batteries that we make from materials on the Earth. And all of those are ultimately residing from conversion of mass into energy as well. So this is a key concept, one of the big ones for the entire course in all of physics. So really, physics is the study of anything, of everything and anything. Try to think of something that isn't related to matter and or energy. Chemistry is a subset of physics. It's about a special little tiny part of physics. Biology is a subset of chemistry and physics, so it's also a part of physics. Just about anything you can think of relates to physics. A Shakespearean sonnet even. Well, you read the sonnet off a piece of paper, there's matter. How do you read it? Well, light energy typically hits the paper. Part of it's absorbed, part of it's reflected. There's some physics, some interactions. The parts that reflected comes back to your eye where it's focused by a lens in your eye. There's some more physics. That focused energy then hits the back of your eye where it hits your photoreceptors, is transferred into electrical and chemical signals, transferred along the neural pathways to your brain, where that energy is ultimately used to create new neural connections, new neurons in your brain to give you the memory of what you had seen on the paper. It's not nearly as romantic when you talk about it that way, but ultimately it's awfully hard to think of something that isn't physics. Given that this is an introductory course, however, we have to limit our scope somewhat. So what you typically see in an introductory level course are topics like mechanics, where you talk about how things move, how work and energy relate to moving objects. You talk about fluids, talk about thermal physics, heat, get into electricity and magnetism. You can talk about waves and optics, and even modern physics, where we discuss in more detail space, time, the conversion of mass into energy, what happens when things get really big or really small. So, to finish off, I'd like you to write down 3 things you'd like to learn about in physics. Then take a couple minutes and see if you can write a few sentences about how matter and energy relate to each of these items you'd like to learn about. Of course, for more information, you can always check out the website, aplusphysics.com, or our Regents Review book has more information on these topics as well. Thank you.